So friends, in my last video, I was discussing about the point group. Now, how to define the point group of a particular molecule. I will repeat again. For example, the molecule, if it is a linear, now linear molecule, if it consists of center of symmetry I, then the point group must be D infinite H. Like carbon dioxide. Carbon dioxide is a linear molecule on the both the ends, and which consisting of oxygen and the center point where carbon is situated. So in this case, center of symmetry I is present. So in that case, the point group of that linear molecule, that is D infinite H. Now, if center of symmetry I is absent, then the point group must be C infinite V. So like HCl, HF, these are the molecule where both the end having heteroatoms, one end having hydrogen, other end having hydrogen, fluorine or chlorine, like that. So in that case, the point group center of symmetry I is absent, therefore the point group is C infinite V. Now, if the molecule is linear, it consisting of a number of subsidiary axes, 2 or more, Cn which stands for number of subsidiary axes, okay, and n is greater than equal to 3, okay. So in that case, where center of symmetry I is present, and along with C5 axes are also present, then the point group is icosahedral. Okay. This is a polyhedral point group. So for polyhedral point group, where it consisting of center of symmetry I along with C5 axis, then the point group is icosahedral. If C5 is absent, okay, C5 is absent, in that case the point group must be octahedral. Now, if center of symmetry I is absent, so then the point group must be tetrahedral, right? Now, on the other side, if this number of Cn are absent, okay, where n is greater than equal to 3, okay, and the point group is Cn. Point group is Cn, and this Cn, which consisting of a number of C2s are present, okay. So this Cn, n stands for C2, and n stands for 2. Therefore, number of subsidiary axes are present, number of C2s are present. So in that case, and if along with sigma H is also present, then the point group is D infinite H. D infinite H. For example, I will give you a BF3 molecule. Okay. BF3 or BCl3 molecule is a linear molecule. Now, where BF3 molecule, where identity E is present, then C3 is present on the Z axis, along with 3 C2s are present. Okay, 3 C2s are present, and which also consisting of sigma H is also present, and 3 sigma V planes are also present. So in that case, the point group is E. The point group is D infinite H. So how to get the point group? E plus C3. The point group is C3. Now C3 plus 3C2. 3C2. Then the point group is D3. Now D3 plus 3 sigma V plus sigma H is also present. Therefore, the point group, now finally we can say that this is D3H. Now on the other side, if sigma H is absent, okay, the number of C2s are present, but sigma H is absent, and in that case, number of sigma D planes are present. So instead of D and H, now the point group is D and D. Okay. So if sigma D planes are present, then the point group is D and D. Now stagger molecule of ferrocene. Now in case of stagger structure of ferrocene, where the point group is D5D, I will explain later on. Okay. Now if sigma D's are absent, then the point group is Dn, right? On the other side, where Cn is present, okay, no Cn are present, and sigma H is present. Then the point group is Cs. However, if sigma H is absent and I is present, then the point group is Ci. Okay. Ci, and I is absent and only identity is present, then the point group is C1. Okay. So these are the lowest configuration point group. Now on this side here, if number of C2s are absent, only rotation axes are present, and sigma H is also present. So in that case, the point group is C3H. Okay, C3H. Like I will give then the chair form of cyclohexane. The chair form of cyclohexane where it has a point group C2H. Point group C2H because it consisting of C2 along with sigma H is also present. So E, C2 and sigma H symmetry elements are present. Therefore, E plus C2 is equal to C2 and C2 plus sigma H is equal to C2H. The point group of chair form of cyclohexane, the point group is C2H. Now, on the other hand, if sigma H is absent and sigma V planes are present, okay, then point group is, instead of C and H, now the point group is C and V. On the other side, if sigma V's are also absent and number of improper rotation axes are present, okay, improper rotations or rotation reflections axes are present, S2N, then the point group is S2N. If S2N is also absent, and then the point group is Cn. So this is how we can derive the point group of a respective molecule. Okay. Now the types of point group. The point groups, it could be divided into 5 types. That first one, that is non-axial. Non-axial, that means it would consist of no rotation axis. So these are the point group where no rotation axes are present. So these are considered as non-axial point group. Second, that is cyclic point group. So it consists of only rotational axis. Rotational axis, or we can say that it could consist of only rotation axis or no subsidiary axes are present. So these are comes under this category. Dihedral point group, that means it would consist of rotation axis along with the subsidiary axis, C2s. Okay, so it would consist of number of rotation axis, principal axis plus subsidiary axis. So they come under this category, D and D or DNH. And these are the special group, that is polyhedral. Polyhedral, that consists of number of symmetry elements. So they are either 3 types, tetrahedral, octahedral or icosahedral. So that we have to remember it. So polyhedral molecules, tetrahedral case, octahedral and icosahedral. So tetrahedral, they are consisting of total of 24 symmetry elements. So therefore, number of symmetry elements are present. Therefore, it would be very difficult for us to point out the or to find out the point group. So that we have to remember. Polyhedral molecule like tetrahedral, octahedral and icosahedral, they are of having number of symmetry elements. Linear molecule. Now the fifth one, that is linear molecules. So point group, that would be divided into 5 types. Non-axial, that means they would not consist of any rotation axis. Cyclic, that means these are the point group, they are consisting of only one rotation axis. Okay, along with either sigma V or sigma H, like that. Third one, they are categorized in dihedral. Dihedral, that means they are consisting of principal axis along with number of subsidiary axis. So they are comes under this category, DN, DND or DNH. Polyhedral, that means they are special group that we have to remember, tetrahedral, octahedral and icosahedral. And finally, linear. Linear, that means the linear molecule either consists of heteroatoms and either consisting of like carbon dioxide, both the end having oxygen, okay, and central atom, that is carbon. So they are having D infinite H point group. However, heteroatoms are there, then HCl, HF, these are comes under this category. They are of having C infinite weak point group. So here, look at this non-axial group. They are C1, CS or Ci. C1, that means it consists of only identity operations. It would consist of only identity operations and rest of the symmetry elements are absent. Therefore, the point group is C1. CS, that means it would consist of identity E plus mirror plane sigma. Therefore, they are comes under this category and the molecule is CS. That we have already discussed earlier. Look at this molecule. This molecule H2C double bond C Cl Br, where only one sigma plane is present along with identity is present. So it would consist of only 2 symmetry elements, E and sigma. Therefore, the point group is CS. Here, C1, this is the molecule where at the terminal site, the hydrogen is there, fluorine is there, chlorine is there, bromine is there. Therefore, in that case, no symmetry elements are present except identity. So only identity is present. Therefore, the point group is categorized as C1. And this is the point group where this is the molecule, the stagger structure. Now, in these stagger conformations, only center of symmetry I is present. That we have already discussed earlier. Okay, and identity is present. Therefore, the point group is Ci. CN group that would be either C2, C3, C4, C5, C6, C7, and C8. So it would consist of only rotation axis. Therefore, there comes under this category C2, C3. Either only C2 axis is present, E and C2. Identity is present and C2 axis is present. Therefore, the point group is C2. E is present and only one rotation axis C3 is present. Therefore, C3, C4 like that. D and point group, that means it would consist of principal axis along with the rotation axis. That means they comes under this category D2, D3, D4, D5, D6 like that. C and V, that means it would consist of only one rotation axis along with sigma V planes. Sigma V plane, therefore C2V. E, C2 is present and two sigma V planes are present, therefore C2V. C3V, for C3V, E plus C3 is present, C3 rotation axis is present, and three sigma V planes are present, like NH3 molecule. So in case of NH3 molecule, NH3 having pyramidal shape, now in that pyramidal shape, the central axis, that means the principal, not principal axis, rotation axis, it passes through the center of that molecule, nitrogen, and while rotating around 120-degree rotations, after 120-degree rotations, all these three hydrogens surrounding that nitrogen, they interchange their positions. Okay, and this is called C3, and three sigma V planes are also present in that pyramidal structure. Therefore, the point group is C3V. I will explain later on about C3 point group. C4V, that means C4 and 4 sigma V planes are present, plus identity is present. Same way, C5, rotation axis is present and 5 sigma V planes are present, plus identity is present, therefore C5V, like that. CNH group, that means it consists of only rotation axis plus sigma H and identity. So identity E is present, C2 axis is present, and sigma H is present. Therefore, C2H. So as I told you earlier, that is the chair form of cyclohexane. So in that case, C2 is present, C2 which is situated on the Z axis, and sigma H is also present, and E is present. Therefore, E plus C2, that is C2. C2 plus sigma H, then point group is C2H. Same way C3H, C4H, C5 and CCH. DNH point group. And now DNH point group, that means dihedral point group, where it would consist of number of rotation axes. Now number of rotation axes, that means principal axes are present along with subsidiary axes are also present. So in that case, sigma H is also present. Okay, sigma H is also present, sigma V is also present. D2H point group. D2H point group, that means naphthalene molecule. Naphthalene molecule where you will find the D2H point group. Okay, so in that case, E is present, then the 3 C2s are present. 3 C2s are present. Among them, one is considered to be a principal axis and 2 C2s are considered as subsidiary axis. Along with 2 sigma V planes are present and sigma H is also present. Okay, and 2 sigma D planes are also present. The point group is D2H. Same way as D3H, D4H, like that. D and D. Now, those molecule where sigma H is absent and sigma D planes are present, then the higher the point group is derived as D2D, D3D, D4D. Okay, so in D and D point group, except sigma H plane, the rest of the elements are same as the DNH point group. Okay, so D2D, D3D, D4H, like that. SN group, that means the improper rotation axes are present. There are S2, S4, S6, S8, S10, like that. Cubic group like tetrahedral group, okay, octahedral, icosahedral. These are some of the polyhedral groups that we have to remember it. And linear group like C infinite V and D infinite H. So in this way, we can define the point group of a respective molecule. So might be understood about this point group. I will give you one example, that means eclipse form and stagger form. Now, ferrocene has two types of structure: eclipse structure and stagger structure. Eclipse structure, that means the upper ring and the lower ring both are merged together and to form a single ring, cyclopentyl ring, and Fe which are present in between that ring. So we consider as a single ring. Okay, so the upper ring and the lower ring both are uh, form a sandwich structure, that is called eclipse form. So here in eclipse structure, what is the point group of eclipse structure? It consists of identity E is present, then C5 is present. C5 is the principal axis. C5 is the principal axis. I will try to show you the this imaginary axis passing through the center of that molecule, and if I rotate it at 72-degree rotations, after 72-degree rotations, this carbon comes over here, this carbon here, this carbon here, and this carbon here. So in this way, so all these 5 carbon interchange their positions. Okay, and therefore this is called C2. This is called C2. Along with along with 5 C2s are also present. These are the 5 C2s. Right. So it passing through the each carbon atoms. Okay, in this way. So this is the C5, and 5 C2s are subsidiary axis. So E is present, identity E is present, plus C5 axis is present, plus 5 C2s are present. Therefore, the point group is D5. Okay, along with where the C2s are situated, that is called sigma V plane. This is one sigma V. Okay, this is second, this is third sigma V, like that. So 5 corners, therefore 5 C2s are there, and 5 sigma V planes are present. So 5 sigma V planes are also present, and sigma H is also present. Okay, sigma H is also present. Therefore, the point group is D5H. E plus C5, then point group is C5. C5 plus 5C2, then point group is D5. Now, E plus C5 plus 5C2 plus 5 sigma V. 5 sigma V planes are also present, plus sigma H is present. Therefore, the point group is finally, we can say that D5H. Same way in stagger structure, instead of sigma H, all the respective elements are present in the stagger form except sigma H. So here in stagger structure, one ring on this side directions, another ring in these directions. That is called stagger structure. Now in stagger structure, except sigma H, the rest of the symmetry elements are present. That we have already discussed in eclipse form. So in eclipse form, sigma H is also present. However, in the stagger structure, sigma H is absent. Okay. So here again I repeat, in eclipse form, E plus C5 is present, plus 5 C2, which is called as subsidiary axis, plus 5 sigma V, and 5 sigma D planes are also present. Okay. Sigma D, where they are situated, they are passing through the angle between two subsidiary axes. In this way. They are passing through the angle between two subsidiary axes, and it divides the molecule into two parts, both the parts which are mirror images of each other. So the red line which indicates the sigma D. So there are 5 sigma D planes are also present. Therefore, plus sigma H is also present. Sigma H is also present. This is sigma H. So here the point group is D5H. Now all the symmetry elements which are present in stagger form, except sigma h. So this sigma h is absent, and the rest of the symmetry elements are present. So what is the difference between staggered form and eclipse form? In eclipse form, all the symmetry elements are present, including sigma h. However, in staggered structure, all the symmetry elements are present, excluding sigma h. Therefore, the point group is d phi d. Okay, and this is d phi h. This is the difference between eclipse structure and staggered structure of ferrocene. So you might be understood about this difference. Look at this sigma d. So where they are situated? Where they are situated? Okay. So either you consider as sigma v or either you consider as a sigma d. Okay. These are the C2. So they are passing through in between the two C2. So if I consider this C2 and this C2 here we consider as sigma d. Okay. So the 5C2, 5 sigma d planes are present. Okay. So I will stop here. So up to the point group is over. In my next lecture, I will discuss about